Okay, Pythagorean theorem, which you guys know, only works for right triangles. So, has to be a right triangle. And Pythagorean theorem is a squared plus b squared equals c squared. The longest side is the hypotenuse. It's across from the right angle, and it's always c. The other two sides are legs, and it doesn't matter which one you call A and which one you call B. You can switch them around. So the hypotenuse is the longest side of a right triangle that is opposite the right angle. So when we say opposite, we mean across the triangle. So we're going to solve, and we're going to leave it in simplest radical form. So this is C, this is A, this is B. So we have 4 squared plus 8 squared equals c squared, or x squared, I guess we could say. So 4 squared is 16 plus 64 is x squared. You have to square before you add. 16 plus 64 is 80. So that means x equals the square root of 80. And the square root of 80 is, just start 2 and 40, 2 and 20, 2 and 10, 2 and 5. So what I'm doing is I'm looking for sad and lonely, stays inside. I end up with 1, 2, 3, 4 2s and a 5. So every time I have a pair, one goes out, one gets crossed out. One goes out, one gets crossed out. And the 5 stays in there because it doesn't have a partner. So I end up with 2 times 2 square root of 5, which is 4, times the square root of 5 would be my answer. For the next one, we know C, but we do not know one of the legs. So I have 10 squared plus x squared equals 26 squared. So what that means is that I have to know what 26 squared is. 25 squared is 625. So it's going to be 6. Wish I had a calculator. $676. Subtract 100 from both sides. Well, I know 2 goes in, and that would be 288. And that would be 144, which would be 12 times 12. So I'm going to stop there, and I'm going to write that. I was thinking that was a perfect square. So I end up with the square root of 2 times 2 times 12 times 12. So 12 can be simplified more, but as soon as I have a pair, one goes outside and one goes outside. So I end up with 2 times 12, which is 24. All right, let's draw a picture. I have a flagpole, and I have the ground, and I have a wire, and here's my flag on my flagpole. And so my flagpole is 25, and this is 20 feet. So I'm looking for the length of the wire, which is C. So I'm going to have 25 squared plus 20 squared equals x squared. 25 times 25 is 625. 20 times 20 is 400. So that's going to be 1,025. So x equals the square root of 1025. That just seems like that should be a perfect square. So we'll go ahead and do this. 5, oh, it's not a perfect square. 5 and 9. All right. So I have 5, 3, and 3. So I end up with 5 times 5 times 5 times 3 times 3. Okay. 5 goes out. 3 goes out. This 5 stays in because it does not have a pair. So I have 5 times 3 times the square root of 5, which is 15, times the square root of 5. Oh, and then of course it said find it to the nearest foot, which means I should have a decimal. And here I am without my calculator, but that's okay. We can figure this out. It is 32 point. So it's 32. So if it says nearest foot, we're rounding, and it's not simplified radical. So our choices are going to be simplified radical. We're going to put it in a radical. If it says to the nearest something, we're going to round. All right, so I have a rectangle. And the diagonal is 16. The height is 8, and we're looking for the length. So we have 8 squared plus x squared equals 16 squared. So I have 64 plus x squared equals 256. So I'm going to subtract 64 from both sides. And I'm going to get x squared equals 192. X equals the square root of 192. I'm going to divide by 2. 96. 2. 48. 2, 24, 2, 12, 2, 6, 2, 3. That's a lot of 2s. 1, 2, 3, 4, 5, 6, and a 3. So let's change colors. And this is going to be the square root of 1, 2, 3, 4, 5, 6 2s. 1, 2, 3, 4, 5, 6, and a 3. So I cross out 3. I have 1, 3 go out. This is left over. So that means I have 2 times 2 times 2 is 8. That's the answer. Okay, triples are kind of magic Pythagorean theorem triangles because all 3 sides are whole numbers. So when we talk about triples, I'm going to use purple. So when we talk about triples, we're talking about all 3 sides are whole numbers. And again, if you don't know them, you can work them out. But, like it says down here at the bottom, when you see them, you shouldn't have to work it out because if you know it, you know it. So 3, 4, 5 is a triple. And all the multiples of that. So if you see 6, 8, 10, that's going to be a triple. So the next one is 5, 12. So I'm going to assume that the 5 and the 12 are the legs. And, whoa, the hypotenuse is what we need. So the third side is going to be 13, which means you could have 10, 24, and 26, which is one of the ones we had above. So any multiple of those 3 works out. So $17 is going to be the C, the long hypotenuse side. So I'm going to subtract. And I'm going to get 15. And then my last one is 7. Okay, those are common triples. If you see them, you should be able to do them without working it out. 3, 4, 5 is the one like that is the easiest one to see because you can also work it out in your head. Okay, how do you tell if the side lengths represent a triangle? The longest side is going to be C. The other 2 sides are going to be A and B. And A squared plus B squared equals C squared. So here's my triangle. And if I want to know if it's a right triangle, the longest side is 34. So if 16 squared plus 30 squared equals 34 squared, then it is a right triangle by using Pythagorean theorem. So It is, yes, because times 16, so this is 900, this is 256, and if you add those together you get 1,156, and 34 squared is also 1,156. So since those are the same, it is in fact a right triangle.